My name is Teddy Dyer, and I'm a leader along with Charles Rooney of the Darien High School Principles of Engineering class. The whole class is basically tailored around building a car from scratch, powered by clean energy, which in this case is a hydrogen fuel cell. And about every 3 years or so, when we complete a car, we take it to a Shell Eco Marathon sponsored marathon and race it against other colleges and high schools, and it's a really awesome experience. Charles and I have had the opportunity to be a part of this class, both as members last year and as leaders this year, but also got to experience the class pre-COVID and during COVID. Pre-COVID, we were sort of on a roll and we were getting much more done much quicker, and I'm sure he can attest to that later. But recently with COVID, we've hit sort of this rough patch because it's with the whole instability, I guess, or uncertainty of whether you'll be in school or not, combined with the different halves of the school and groups being split up. It's kind of tough, but I would say this year we've done a pretty good job making some meaningful progress in the car, and and that's what we're going to showcase in this video.
Okay, so there are different categories of how to approach building this difficult project. Me and Teddy kind of decided to break everything up into different groups. So obviously there's different parts of a car that we have to make because we're actually building a car. So there's an electrical portion of it. There's the seat and steering portion. There's the carbon fiber portion, which is the bodies and like the panel. It's kind of just like the outside of the car in general. And then there's kind of just like we have a social media team. We just kind of all work together to defeat this monster of a task in building a car. It's definitely much easier to all work together in our different groups. And I think we made pretty good progress this year. Later on in the video, we're going to go into specifics as the members of each group will give you kind of an overview of what they actually do. And yeah,
very good, very good group of kids. So we took what we were given this year, and we made the best of it. And you honestly can't ask for much more than that.
The electrical system here, and we have two heads-up LCD displays which are going to basically show our driver, its speed, the temperature of the motor, make sure everything's all right, give it necessary information. This here is the hydrogen sensor, so if there's any leaks inside the fuel cell, this hydrogen sensor will be able to detect it and alert the driver. This here is our DC to DC converter. This is basically going to be keeping our entire system running from this battery, and what's interesting about this is we only need 1 joule from this battery. So this can be completely detached from the actual system as soon as we press the start button. Because what this does is it keeps depowering and powering these batteries so they charge and recharge themselves over and over again. That's basically what this DC converter does. Now these two connectors are basically going red on red and black on black. And they're going to be keeping power going from our battery into the system here. This is our on button, which is going to be located on the steering wheel for easy accessibility to the driver. Now this crystal line controller is going to be what's controlling our motor in the back, telling it how fast to slow down. These two emergency stop buttons are both going to be used to actually stop the vehicle. One's going to be located on the steering wheel, and one's going to be located on the exterior of the vehicle in case of an emergency and rolling over or something. Maybe the driver can't necessarily get the button. Now over here we have our two connectors which go into the fuel cell, which of course has its necessary tubings and stuff. This here is a purging valve for the H2O that will come out as a byproduct. This right here is the entry valve for our hydrogen, so we get our supply of hydrogen coming in. This over here, this is actually what we run the entire system on. It's got our software on this, all the stuff we need. Of course, we have this little sensor right here that'll tell us if there's any actual power in the battery. Now, I wish we could start it up and show you that everything works, but right now we're waiting for another battery to come, since we have reason to believe that this one is either dead or corrupt. And yeah, that's pretty much it.
It's a rough design that we created throughout our work this semester, and we did a lot of designing, both more physical sense with this and also online using Onshape. So when we started off, we really didn't have much of a starting point to begin with, other than knowing that it had to fit in this frame, and we knew that we had to have the dimensions of our driver. So that was how we started off, by getting those dimensions of the driver and looking at how we would use those in relation to the frame of the car while making a scene. We took a lot of inspiration from aluminum racing seats, and eventually, if we were to make a final model of this, it would probably be out with some sort of lighter metal like wood. So when we designed it, we used Onshape, and we started off with very rough designs, as you can see here, and we then went into a lot more depth in the designs, as you can see here, and then eventually we went to the physical model, which is here, and use foam board to create that, and hot glue. And this is still a very rough design, but we've definitely improved it a lot throughout the semester from what we started with originally on Onshape. And so some problems that we still have are that we have to make it fit better for the seatbelt. Like for instance, these slots right here have to be turned so that it can go in more easily. We have to make it fit the frame better and have it be mounted to the car in such a way that it's more realistic to what the final product will actually look like. Chances are the driver that we had measured to use for this is not going to be the actual driver of the car, so that's something else to think about for other groups moving forward. And so, yeah, that's pretty much our process.
So carbon fiber is made out of carbon fiber sheets, honeycomb, epoxy, and you first want to cut out your pieces so they're equal. They're about equal sizes. If they're not, you can always trim after. Then you want to make sure you wax down your board so it doesn't stick when you put epoxy on it. And then you want to pour it on. After applying the epoxy to both sides of the sheets, you want to then put on the honeycomb on one of the sheets and press it down a little bit. Then you're going to grab the other sheet onto the wax. And you're going to carry it over. And you're going to make sure you line it up with it.
The carbon fiber group designs and creates panels to the outside of the car so the driver is enclosed inside the vehicle with an easy way out. And they design and create it as lightweight and as slim as possible so the car can be as efficient as possible. And what we accomplished this semester is sides to where the electrical gear is located so it's enclosed and safe. A rough sketch on the complete car and an idea how to make the curved edges, which we'd use foam to make a mold. Problems this year, we messed up on the epoxy mix a couple times and we had to redo a piece. We ran out of epoxy and honeycomb and could not make any more. And without being fully in class, it was hard to plan out the car and it was hard to make stuff when we were split up into 2 days.
Our role as a welding team is to weld certain pieces of metal together that the other team members requested us to do and cut pieces of metal to suit the fuel cell car. Our goal for the future is to help the team with the welding and create a total front end of the fuel cell car.
In welding, we had a few issues that kept us from moving forward. One of the main issues being running out of welding gas. We were unable to weld for about 2 weeks, which made us lose vital practice and work time. Along with that, COVID also caused many issues, as we had many kids out due to contact tracing and quarantine, which included some welders that didn't allow us to have as many sets of hands working on welding.